Good day, students. Welcome to mathgodserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the Algebra 2 Common Core Regents exam for June 2016. If you have any questions about the contents of this presentation, just feel free to ask your questions in the comment section below. I'll be glad to provide you with support. Alright, let's take a look at question number 1. It reads, when b greater than 0 and d is a positive integer, the expression 3b raised to the 2 over d is equivalent to. Now, to help us rewrite this problem using radical notation, you want to remember the rational exponents property. Okay, so if you have a power raised to a fractional exponent, so let's say we have a raised to the m over n, let me color code it here, m over n. So this is writing it as a rational exponent. If you want to write this in radical notation, what happens is that the power, the numerator stays a power, okay? So the numerator stays a power, and the denominator becomes an index of the radicand, okay? So this is the denominator, this becomes an index, and then the numerator always stays as a power. Okay, so let's go ahead and apply that idea here. So if you look at this formula, we can write this as a to the m. Notice the power stays a power, but the denominator of that rational exponent becomes the index of your radical. Bam, the nth root of a to the m. Okay, now this power can be a radicand, or it could be the power of the radical. Okay, so this is one format of expressing this as a radical. Or you can write it as the nth root of a, the entire thing raised to the mth power. So all you just have to remember is that the power stays a power, but the denominator of the rational exponent becomes the index of your radicand. Okay? So let's go ahead and apply this idea to this problem that we're dealing with here, 3b raised to the 2 over d. So we have quantity 3b raised to the 2 over d. Alright, so if I want to write this as a radical expression, there are two formats I can use, okay? The first one, I can write this as the second root, the d root, since the denominator becomes your index, the d root of what? Of quantity 3b raised to the second power. This is one way I can write this exponent as a radical form. Alright? Just using this format, we can clearly see that our answer is option number 4. There's another way in which we can write this. We can write this as the d root of 3b, the entire thing raised to the second power. Okay? So actually, this format is more consistent with the results that we have over here. Okay, so remember, there are two ways of writing an exponent with rational powers in radical form. Alright, let's go ahead and take a look at question number 2. It reads, Julie averaged 85 on the first 3 tests of the semester in her mathematics class. If she scores 93 on each of the remaining tests, her average will be 90. Which equation could be used to determine how many tests T are left in the semester? So one thing you want to note concerning how to find the average of a data set is basically the sum of the values of the data set divided by the number of values that you added. Okay? So let's go ahead and write down the formula that we're going to be using for this problem. I'm going to adapt this average formula to this scenario. So formula. Alright, average. What is the average? The average score is basically given by the total score divided by the number of scores. Okay, how many tests did she take, right? So this is the formula we're going to be using. Now there are two scenarios happening here. Okay, first of all, we have some information concerning the first three tests, and then we're supposed to use that to determine some information concerning all the tests in a semester. So to assist us with this problem, we're going to break it down. We're going to consider the first scenario where we have just three tests. Okay, so for the first three tests, we're going to be writing down some equations and carrying out some computations. So for the first three tests, how many scores were there? Number of scores. Number of scores were 3, right? 3 tests. Now, what was the average score for the first 3 tests? Average score was 85. Now, for the first 3 tests, what is the total number of scores? Total number, total score. Okay, there's no need for a number here. So what is the total score for all the 3 tests? Now, to answer this question, what we're going to do, let's write this down, total score. Let's go back to the problem. Total score for the 3 tests. If we look here, we're given the average for the first 3, and that's basically it. We know that it's 3 tests and an average of 85. Can we use this information to determine the total score for the 3 tests? Okay, so total of 3 scores is what? Total of 3 scores is unknown. We don't know what the answer is, so we're going to go ahead and calculate it. Okay, so let's go ahead and call up the formula that we wrote over here that's going to assist us in the computation process. So the average score, or just put average, is equal to total of the 3 scores, that divided by the number of scores. Okay, so that's just the formula adapted to this situation, number of scores. Okay, so in this problem, the average score is 85 for just the first 3. The total of all 3 scores we do not know, so let's leave it as total of the 3 scores. And how many scores are we considering here? It's 3 scores. Okay, now let's solve this equation for the total number of scores. Simply multiply both sides by 3, and then you end up with a total of the 3 scores, as you just multiply 85 by 3 and you get 255. So that's the total of the 3 tests that she took. Okay, so we'll just keep that information in mind. Let me divvy up my workspace here. Okay, now the second scenario has to do with all the remaining tests, all the tests that she took that semester. Okay, so remember, she took 3 tests and then she took T more after that. Okay, those are the number of scores that are left at the end of the semester. So how do we title this? We can call this 3 initial plus T tests. What are the equations that we can generate using this information? Okay, so now considering T plus 3 tests, the total number of tests in the semester, we're going to write down the known and the unknowns and see if we can set up an equation. Okay, so how many scores were there? Number of scores for the entire semester. Number of scores for the entire semester were the first 3 plus the T that are left in the semester. Okay, and then the average, what was the average score? The average score was indicated on the problem as 90 after adding T scores to the original that she had here. Alright, so we have number of scores, we have average, we need the total scores. Okay, so the total of not just 3, not just t, but 3 plus t scores. What is the total? Well, this can be given by the total number of the 3 scores, which we computed to be 255, 255 plus. Now, this is the information here. We're told that um, she scored 93 on each of the remaining tests. How many were remaining? T. So if you score 93 on each one and you have a total of T, your total score for the T test is going to be the quantity times amount, which is 93 for each one times the total number of tests, which is T. Okay? Alright, let's go ahead and rewrite our formula. Average is equal to total of the scores divided by the number of scores that there are, which is basically the same as the number of tests that she took that semester. The average score for 3 plus t tests is 90. Total number of scores is 3 plus t scores, that's what we're talking about, is 255 for the 3 tests plus 93t for the last t, which she scored 93 for each. And then we divide that by the number of scores. The number of scores, we already know what that is. 3 initial plus the remaining t. Okay, so this is the equation that we can solve for t to determine how many tests or how many scores she got for the remainder of the semester. Okay, so if you look at that, this answer right here, it is consistent. Let's see, with option number 3. So that's the answer for question 2. Okay, let's take a look at number 3. It reads, given I is the imaginary unit, the quantity 2 minus yi raised to the second power in simplest form is. Now, one tip concerning expanding difference of terms is that you want to pay close attention to that negative. Okay, that negative when you're expanding binomials could be a source of error. Okay, so you want to pay close attention to that. Now, another thing you want to keep in mind is whenever you have I raised to a power that's greater than 1, you have to simplify. Okay, it can be reduced. So let's go ahead and take a look at what the reduction is. So if you have I is just I to the second power is negative 1. I to the third power is the product of these two, which is negative I. And then I to the fourth power is negative 1 times negative 1, which is 1. So every other power of I, you can just wrap them around here. So this is I to the, this is 4, I to the 5th, I to the 6th, I to the 7th, I to the 8th. And then this pattern just keeps repeating itself. What you want to remember is the first 4, okay? Because everything just falls into one of these categories. Just count and identify where you fall in, all right? So let's keep that in mind. Now, let's go ahead and write this in its simplest form. It's basically asking us to expand. So we have 2 minus yi raised to the second power. Okay, so what we're going to do here is avoid a common mistake most students make. Okay, this is a mistake some students make. So if they say, okay, I have x minus 2, for example, raised to the second power, they just distribute that to these and this and this, and they say, oh, it's x squared minus 4. Is that correct? That's absolutely wrong, okay? When you're squaring a quantity, what you're doing is multiplying that quantity as a whole by itself. So we have 2 copies. Okay, so this is how you write it, and then you just expand. First, outer, inner, last. Your formula for expansion of binomials. Okay, let's multiply this out. 2 times 2 is 4. 2 times negative yi is negative 2yi. Negative yi times 2 is negative 2yi Minus times minus, be careful there, which makes this a plus. And then we have y times y square, I times I to the second power. Okay? So when you're multiplying y and I, you just do the variables and then the letters afterward. Now let's go ahead and simplify. We have 4 minus 2yi minus 2yi. You just focus your attention on the coefficients. What is negative 2 minus 2? The signs are the same, so you add and keep the sign. Negative 4, right? The same pattern applies here. Negative 2yi minus 2yi is negative 4yi plus y squared. Now, can I to the second power be reduced? That's the question. And the answer is yes. Remember, we talked about it earlier that if you have a power of I that's greater than 1, it can be reduced. The goal here in this problem is to find the simplest form, so we have to reduce it. We're going to use this row right here. I squared is equal to negative 1 to assist us in simplifying this term. So I squared is going to become negative 1. Okay, let's go ahead and simplify a little bit more. We're going to have 4 minus 4yi minus y squared. And then we can just rewrite it. We're going to have negative y squared minus 4yi plus 4. Okay? And our answer, let's see, minus minus plus y squared for yi is option number 2. Okay, let's take a look at question number 4. It reads, which graph has the following characteristics? It has 3 zeros. It has, as x approaches negative infinity, the function approaches negative infinity. And as x approaches infinity, the function approaches infinity. Now, one thing you want to note concerning the zeros of a graph and what the graph of that function looks like is that the number of turns on a graph of a polynomial is at most 1 less than the number of real zeros, which is the same as the number of degrees. Okay? So what on earth am I talking about here? In this problem, we're told that we have a total of how many zeros? 3. So based on what I stated in this point to note, you can have at most how many turns? You can have at most 3 minus 1, which is 2 turns. You could have less, but you cannot exceed 2 turns. So let's look at the graph and see if this fact can aid us in eliminating distractors. Option 1 has 1, 2 turns, so that's good. Option 2 has 1, 2, that's 2 turns, that's good. Option 3 has 1, actually this is option 3, this is option 2. Option 2 has 1, 2, 3, that's 3 turns, no good. Option 4 has 1, 2, 3 turns, way too much, that's no good. Okay? The number of turns can be at most 1 less than the number of real zeros. Okay? Alright, so now which one is the correct answer? Option 1 or 3? That's where the end behavior will come to play. Okay, so let me give you a guide that can help you really understand how the end behavior works in classifying how a function behaves at the right and left ends. So let's go ahead and draw a coordinate system. So say we have a coordinate system like this, like that. Okay, so let's label our f of x and our x, our dependent and independent variables. So our dependent variable, this is x right here, and our independent variable, this is f of, no, this is our independent and this is the dependent f of x. Now this is the end behavior. If you go up forever, where do you end up at? Infinity. Okay, that indicates increment in the direction of the y. If you go down forever, where do you end up? Negative infinity, way down here. That indicates decreasing in the direction of the y, or f of x. That's basically the description of the end behavior of our vertical axis. Now let's direct our attention to the horizontal axis. At the left end, we have negative infinity. That's way at the left. And then on the right end, if you keep going right forever, you end up at infinity. You can't really get there, but it's just theoretical. As a large number that keeps getting bigger. No upper bound. Okay, and that's at the right end. So let's look at what the end behavior is telling us. It says as x is going to negative infinity, where is negative infinity in the x direction? As x is going to the left, okay, the function is going to negative infinity, which means where is negative infinity for the function? Down. So if the function is going to the left, the function is decreasing. Okay? So negative infinity, the function is decreasing. So guess what? The left end behavior is going to end up in quadrant 3. Because as you go to the left, the function is decreasing. Now let's take a look at the right end. As x heads to the right, what is the function doing? As it heads to the right end, namely infinity, the function approaches infinity. Infinity involves increasing. So at the right end, we're going to end up in quadrant number 1 because as the function heads to the right, the function is increasing at infinity. Okay? And then in here, we're going to have a total of 2 terms because there are 3 real zeros. And the number of terms is always 1 less than the number of zeros. So let's look at the end behavior of these 2 graphs we have here. Which one is consistent with this? Which is increasing in quadrant 1 and decreasing somewhere in quadrant 3? We can clearly see that our correct answer is option number 3. Alright, let's take a look at question number 5, the last one in this review installment. It says the solution set for the equation root 56 minus x equals x is. Now, one thing you want to keep in mind concerning radical equations, solving radical equations, is that you always want to identify and eliminate extraneous solutions by checking all your results. Okay, that's very important because there are constraints on the domain of the radical function. So when solving by squaring both sides, you might inadvertently introduce extraneous solutions to your answer. So those extraneous solutions that are not solutions to the problem, can only be identified by you checking your results, plugging your answers back into the original problem. Okay, so let's go ahead and solve and not forget to check. So let's solve this. So what you're going to do, first of all, our goal number 1 is to eliminate the radical. Alright, so we have root 56 minus x equals x. So we're going to use the inverse of the radical operation to eliminate the radical function. The inverse of radical of root is square. So we square both sides, okay? Now when you square both sides, you end up with 56 minus x equals x squared. This, ladies and gentlemen, is now a quadratic equation. We have converted a radical equation into a quadratic. How do you solve quadratics? Most methods involve you putting it in standard form first. Okay, so let's go ahead and do that. Let's put it in standard form. Simply subtract 56 from both sides and add x to both sides. Okay, so now we're going to have the quadratic in standard form: x squared plus x minus 56 equals 0. Now let's go ahead and solve this by factoring. This is a viable approach because if you look at the distractors, the options that we have, they are all integers. So the nature of the options automatically tell me that this is a factorable scenario. If I had i's or radicals there, then I wouldn't even bother trying to factor. I'll just use a quadratic formula because the related equation will be prime. So I'm going to put AC on top. AC on the top, and then B goes on the bottom. So this is A1, B is 1 also, C is negative 56, AC is negative 56, B is positive 1. Okay, so let's play the X game. What two numbers add to give you negative 56 and multiply to give you 1? Oh, I'm sorry, got it backwards. What two numbers multiply to give you negative 56 and add to give you 1? Much better. So think about all the multiples, all the product of numbers that yield 56. Answer is 7 and 8. But since the sum is positive, the smaller has to be negative. So these are the two numbers that work. So plug them here. We have x minus 7 times quantity x plus 8. Okay, so that equal to 0. Now we are going to use the zero product property to set both factors equal to 0. And then we're going to solve. To solve the first one, you add 7 to both sides. And then you have your first potential answer, x equals 7. And then the second one, you subtract 8 from both sides, and you have x equals 8, negative 8. So our answers, our solution set 7 and negative 8 as illustrated in option 1. The answer is we do not know yet. How do we know if these two answers are correct or one of them is extraneous? To identify and eliminate extraneous solutions, we must check both answers, not just one. Okay? So let's start by checking out x equals 7. Now, how do we do this? We plug in this into the equation and ask ourselves, is 56 minus 7, is it equal to question mark 7? So what I'm doing is I've plugged in x 7 for x in the original equation. Okay, let's simplify this. 56 minus 7 is 49. Is the square root of 49 equal to 7? We know the square root of 7, the square root of 49 is 7, so 7 equals 7. Check. X equals 7 is a solution. Now let's move on to the second one. We have to test both answers, okay? Now we have x equals negative 8. Plug that in and ask yourself, is 56 minus negative 8, is it equal to x, which is negative 8 in this case? Is this true or false? Put a question mark there because we're unsure. Now we have minus and a minus, so we slash and dash, that becomes a plus. So we have the square root of 56 plus 8. Is it equal to negative 8? That's the question. 56 plus 8 is 64. Is the square root of 64 equal negative 8? What is the square root of 64? 8, right? Is 8 equal negative 8? The answer is no. X equals negative 8 is extraneous. It doesn't, is not a solution to the problem that we're trying to solve. All right? So we're going to eliminate that. And that tells us what the solution set is. So the solution set has only one element, which is positive 7. There goes your solution set. Answer is option number 3. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, please give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to this channel so you can gain updates to the remainder of this review series. If you have any questions about the contents of this tutorial or any questions on the Algebra 2 Common Core Regents exam in general, just ask your question in the comment section below, and we'll be more than glad to support you. More clips can be found on math.serve.com under test prep. Thanks again for watching, and have a wonderful day.